Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are Math 8, we're working from the Course 3 textbook. We are doing lesson 10.5, reading scientific notation. And it can be found on pages 438 and 439. So what is scientific notation? Scientific notation is a way of writing numbers that are very, very large or very, very small. It's a way of writing numbers, very large numbers and very small numbers, in a way that we can use them. And then we don't get mixed up or messed up with how many place values there are or how many decimal places. So it's a way of simplifying very large or very small numbers. And scientific notation is written like this: 8 3/10 times 10 to the negative 7. So when we have something in scientific notation, one of our factors, typically our first factor, is a factor that is 1 or greater and less than 10. So this first factor needs to fall here. It needs to be 1 or greater than 1, but less than 10. And then our second factor is a positive or negative power of 10. A positive or negative power of 10. So this is what scientific notation looks like. Our first factor is here, it's 1 or greater and less than 10. So it falls between 1 and 10. And our second factor is a positive or negative power of 10. And this is a way of simplifying really large or really small numbers so that we don't get messed up or tripped up on all the place values. Okay? So the first thing I want to do with you, let's talk about whether these are written in scientific notation or not. 5 9/10 times 10 to the negative 6. Is this written in scientific notation? Well, the first thing we need to ask ourselves, is this factor 1 and greater and less than 10? Is this factor between 1 and 10? Yeah, it is. So this is between 1 and 10. And then this factor, is it a positive, negative power of 10? Yeah, it's a negative power of 10. So is this written in scientific notation? Yes. This is written in scientific notation. So let's take a look at another one. 0 9/10 times 10 to the 8th power. Is this written in scientific notation? Well, let's find out. Is our first factor between 1 and 10? Is 9/10 between 1 and 10? That would be no. 9/10 is less than 1. 9/10 is less than 1. So this is not between 1 and 10. And we're done. So this is not scientific notation. And you're done with it. So for it to be scientific notation, your first factor has to be between 1 and 10, and your second factor is either a positive or negative power of 10. So let's talk about turning scientific notation into standard form, reading scientific notation and turning it into standard form. So we have 3 and 22/100 times 10 to the negative 4. The first thing we have to figure out, is this scientific notation? Is my first factor between 1 and 10? Yes. 3 is greater than 1 and less than 10. So yes, it's between 1 and 10. My second factor is a negative power of 10. So yes, this is written in scientific notation. But now, how do we read this? How do we read this? If we have a negative exponent, we're moving the decimal to the left. That means we're making this number smaller. So a negative exponent means we move the decimal to the left. And we're making this number smaller. So we have 3 and 22/100. I have a negative exponent. I'm moving my decimal to the left, and I'm going to move it to the left 4 places. 1, 2, 3, 4. Here's my decimal point, and I backfill with zeros. So my standard form looks like this. And that kind of makes sense. 10 to the negative 4th. Well, yeah. So because it's negative, we're moving the decimal to the left, and we move it to the left 4 places. Okay. Well, what happens? 7 and 9/10 times 10 to the 5th power. What happens if we have a positive exponent? First, we need to ask ourselves, is this written in scientific notation? Is my first factor between 1 and 10? Yes. 7 and 9/10 is greater than 1 and less than 10. And I have a positive power of 10. So here I have a positive exponent. I have a positive exponent. So that means I'm going to move my decimal to the right. I'm going to make this number larger. So I've got 7 and 9/10. My decimal is going to go to the right, and it's going to go to the right 5 places. 1, 2, 3, 4, 5. Here's my decimal point, and I backfill with zeros. And it kind of makes sense. 10 to the 5th power is 10 times 10 times 10 times 10 times 10, which is 100,000. We're multiplying 7 and 9/10 by 100,000. So my answer is 790,000. It makes sense. So to make it a little bit easier, if we have a positive exponent, our decimal moves to the right, and it moves to the right this many places. Okay, let's do a couple more examples. Okay, we've got 12 times 10 to the 4th power. The first thing we have to do is ask ourselves, is this written in scientific notation? No, it is not. 12 is greater than 10. 12 is greater than 10. So this is not scientific notation. So you're done. If it's not written in scientific notation, you do not have to write it in standard form. You're done. Okay, we've got 6 times 10 to the 7th power. Is this written in scientific notation? Is my first factor between 1 and 10? Yes, it is. And I have a positive power of 10. So this is written in scientific notation. The 7 is positive, so I'm moving my decimal to the right. And I'm moving it to the right 7 places, but I don't see a decimal. Where's my decimal? Every number has an invisible decimal behind it. So here's my decimal. So it's positive, I'm moving to the right, and I'm moving to the right 7 places. 1, 2, 3, 4, 5, 6, 7. Here's my due decimal point, and I backfill with zeros. And that kind of makes sense because this is really 10 times 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7, which is 10 million. So if we're multiplying 6 times 10 million, our answer is 60 million. So moving our decimal point to the right 7 places makes sense. Okay, we have 9 and 9/10 times 10 to the negative 5th power. First question, is this written in scientific notation? Is my first factor greater than 1 and less than 10? Yes. And I have a negative power of 10. So yes, this is written in scientific notation. I have a negative exponent, which means I'm moving my decimal point to the left, and I'm moving it to the left 5 places. 1, 2, 3, 4, 5. Here's my new decimal point, and I backfill with zeros. So this is what it looks like in standard form. And we've got one more example. One more. 1 and 285 thousandths times 10 to the 4th power. Our first question, is this written in scientific notation? Is this greater than 1, less than 10? Yeah, it is. And we have a positive power of 10. So my exponent is positive. I'm moving my decimal point to the right, and I'm going to move it to the right 4 places. 1, 2, 3, 4. Backfill with your 0. So 12,850 is standard form for this number written in scientific notation. So that's what we're doing today. The first thing you ask yourself, is it written in standard notation? Then, if it's a positive exponent, you're moving your decimal point to the right. And if it's a negative exponent, you're moving your decimal point to the left. That's what we're doing today.